Good morning, students. So today we are going to start with another topic that is called as sewage treatment. Before going for that one, just remind me the previous class. So in the yesterday's class, we have studied about the analysis of water component. That too, particularly, we have studied about the determination of amount of sulfate present in a given sample of water. So this sulfate ion content is determined by the gravimetric estimation. The gravimetric estimation is nothing but first we are supposed to precipitate, then the precipitate is washed thoroughly, then it is dried, then it is ignited. After ignition, then it will be cooled to the room temperature and then wait the repeatedly we are going to ignite it and cool it, and then when we'll get a constant weight, then we are going to find the amount of sulfate. So we know that the BaSO4, the molecular formula of a BaSO4 is 233.3. So this 233.3 grams of BaSO4, barium sulfate, is going to contain 96 grams of SO4. So W is the weight of a precipitate that we get. Then automatically we are going to use W into 96 divided by 233. We are going to do it. Then by getting the amount, we are going for it will be multiplied with it is multiplied with 1,000 so as to convert it in terms of mg per dm cube. So in this way we are going to do. So to the procedure wise, if you take, so the water containing the sulfate is treated, it is treated with a BaCl2 in acidic medium. Initially, we are going to take about 200 ml of water and it is boiled. Once it is boiled, then it is acidified with concentrated H2SO4. Dropwise, we are going to add. So once it is acidified, slowly we are going to add BaCl2 with a constant stirring. The concentration of a BaCl2 is going to be 10%. So 10% solution of a BaCl2 is slowly added with a constant stirring, and that will lead to the formation of a BaSO4. BaSO4 is a white PPT that we are going to get. Once it is precipitated completely, then the solution is digested for about 2 hours. So the purpose of digesting is the complete precipitation, and apart from that, to reduce it further, the volume has to reduce further. So the digestion is nothing but the heating any solution below its boiling point is called as digestion. Once it is digested through using a filter paper, so here we are going to use a filter paper which is going to be ashless filter paper. So this ashless filter paper is taken, and with the help of a Bush crucible. The purpose of using the Bush crucible, it is a type of a filtration unit which is used with the help of a vacuum. We are going to filter it. Since the BaSO4, the barium sulfate precipitate, is colloidal in nature, due to that it cannot settle at the bottom that easily. So to get it properly filtered, it will be filtered with the Gooch crucible. So once it is filtered, then we are going to dry it using a aluminium cone. Once it is dried, then it is put into previously weighed silica crucible is used. In that we are going to place it. Then first it will be heated slowly, then afterwards it is heated to a dry hotness, a red hotness. We are going to say that it means that the entire crucible, it becomes a red like a fireball. Then till that time we are going to heat it. Once all the PPT and the paper get ignited, then we are going to cool that crucible. Once that burner, or once the oven comes to the normal temperature, we are going to remove it from there and we are going to cool it in a desiccator. Once it is cooled, then weight of the crucible with the PPT is taken. Then the difference between the weight of a crucible and the weight of a crucible with a PPT, between these two difference we are going to take, and that will give us the amount of sulfate, barium sulfate, formed by addition of HCl solution. BaCl2 solution. So in this way, we are going to find out the amount of a sulfate present in a given sample of water. Now, in case of determination of a fluoride is concerned, this is purely based on colorimetric estimation. We all know that colorimetric estimation is nothing but comparing the colors. If the colors are matching, then the concentration is going to fall in that particular range. So here in this case, first we know one simple principle, that the zirconyl Spans reagent will be get bleached by fluoride. That's a concept known to us. Using that one, we are going to find out the concentration of a fluoride. If the fluoride content is more, then the color of the bleaching action on the zirconyl Spans reagent is going to be more. If a color of a zirconyl Spans reagent is more, it indicates that the amount of fluoride that is present in a solution is going to be less. So using this one, we are going to find out the fluoride ion concentration. Here we are going to prepare the zirconyl chloride solution separately, and at the same time we are going to prepare the Spans reagent separately. These two are mixed equal volume. So supposing that we have taken a 10 ml of Spans solution, then you are going to take a 10 ml of zirconyl chloride solution. Both you are together, you are going to mix it. So in the preparation of zirconyl chloride solution, usually first it is dissolved in a 25 ml of water. Then to this around 300 ml of concentrated HCl is going to be added. After that, again water is added and it is diluted to 500 ml. So in this way, the zirconyl chloride solution will be prepared, whereas the Spans reagent, a weighed quantity of a Spans reagent is taken and it is dissolved in a known volume of water, and then it is diluted to 500 ml. See, these all solutions based on the requirement of a experiment. If you need more volume of a stock solutions, we are going to prepare the more. If it is requires less, then we are going to prepare less. Then similarly, we need to prepare a standard solution. To prepare the standard solution of a fluoride, we are going to use anhydrous sodium or fluoride salt. It will be weighed quantity of sodium fluoride solution. So salt is taken, then it is dissolved into a water, and then it is further diluted, so that the 1 ppm, 2 ppm, 3 ppm, 4 ppm, in that way we are going to get the concentration. Then we are going to find out the optical density. We are going to take 1, 2, 3, 4, 5 in that way. 10 ml of sodium fluoride solution is taken in a 50 ml of volumetric flask. To that we are going to add known quantity of this zirconyl Spans reagent. Then we are going to find out the optical density of all these 10 standard solutions. Then by knowing that optical density, we are going to plot the calibration curve. Using that calibration, the same procedure is followed with the test solution or the test water. Then the optical density of an unknown solution or the analyte solution is going to be marked on the calibration curve. From the calibration curve, we are going to get the concentration. So in this way, we are going to find out the amount of a fluoride present in a given sample of water. So this is how we are going to determine the two different ions or the two different compounds, that are two different radicals that are present in case of water. Now we are going for the last, probably this is the last topic that we are going to cover in case of fourth module, but very important topic, usually asked in the examination. Write a note on secondary sewage treatment. That is, sometimes it will be asked in this way, and sometimes it will be asked as write a note on activated sludge treatment. So activated sludge process is used to remove the sewage, the load that is present in a sewage. So now we are going for this sewage treatment. Sewage water is nothing but it's a waste water from waste from the kitchen, laundries, bathrooms, laboratories, industries. It is the waste that coming out, liquid waste that coming out of these things. It may be from the kitchen, it may be from the laundries, it may be from the bathroom, it may be from the laboratories, or it may be from the industries. So the generally the domestic sewage contains heavy load of BOD. Heavy load of BOD in the sense it's going to contain more amount of organic load. Along with that, it's going to have the pathogen bacteria. It's going to have a color. It's going to have a dark color, and it's going to have a odor. Odor is nothing but a bad smell it is going to have. So all these are going to be present in that. This sewage water discharge into the water bodies leads to, if you discharge this water into natural water resources, automatically it leads to the deficiency of dissolved oxygen. Means it consumes the oxygen that is present in a water resources, and apart from that it will be get contaminated with pathogen bacteria, which will lead to the waterborne diseases. So that's why before releasing any sewage into a natural water resources, we need to treat it. So this treatment involves three steps. The first one is a primary treatment, second one is a secondary treatment, third one is a tertiary treatment. So the three different treatments are going to be there. If a sewage undergoes these three processes, automatically it is going to be a water usable for our domestic applications. So in generally, that type of water we are again regenerating. That is, sewage is converted back into a fresh water by using these three different processes. So the first one is a primary treatment. Primary treatment is nothing but it is a physical treatment. So it removes the suspended impurities, or it removes the impurities which are physical in nature. Either it may be a floating material, or it may be a suspended particles, or it may be containing a heavy pieces like glass pieces, metal pieces, or dust, that is sand or soil, any clay if it is present, that will be removed in case of this primary treatment. So this primary treatment is involving again 4 steps. The first one is the screening, second one is a filtering, fourth one is the removal of oil and grease, then the fourth one is the sedimentation. So these are the 4 steps that are going to occur in case of this primary treatment. Then comes the second treatment, that is in that screening. Before going for the second one, let me tell about the screening. Screening is nothing but it is a physical process which removes the large suspended or a floating matter in a sewage water. It is accomplished, or it is done by passing through the bar screens or mesh screens. So it is nothing but it is a filtering action. So if the floating material is a large in size, then in that case we are going to use a bar screening. Bar type of screening will be there. Through that we are going to pass the water. Once it is passed through that one, only the water will flow at the other side. The suspended or the floating impurities that are going to be present in the water, it will be retained at the other side. So just normal filtering it will be there. So either we are going to use a bar window, or else the mesh window we are going to we are going to use it. So in this way we are going to remove the suspended or the rough large floating impurities that are going to be present in case of a sewage water. Then comes the slit and grit removal. Generally we call this one as a filtration. A slit and a grit in the sense these are going to be as pieces of a glass, pieces of a metal, or pieces of any heavy metal which are passed through the bar screens, or which are passed through the mesh screen, that we want to remove it. So here what we are going to make is we allow it to flow. The water is made to pass through the grid chamber, where the velocity of water, the flowing of velocity of flow of water is going to be reduced. Once it is reduced, automatically the heavier particles settles at the bottom. Only the lightweight water molecules keeps on moving. So by doing that one, the grit and the slip is going to settle at the bottom. The heavier metals are going to settle at the bottom, and that can be removed. Only the transparent or only the lightweight impurities will be carried with the with the with the water. So this is done in case of a second method. Then we are going for the third one, that is the removal of oil and grease. If water is contaminated or water is associated with oil or a grease, then in that case it has to be removed. So the only way that can be removed is by skimmed tanks. So we are going to subject, or we are going to collect this sewage water into a skimming tanks, and these are converted into a soapy mixture by blowing a compressed air. Continuously, the compressed air is bubbled inside the water. Due to that, the oil and grease that are going to be present in a water, they will form a froth, they will form a foam, and that foam is going to float on the surface of the water, that will be skimmed off, that will be removed from the top, and the oil and the grease is going to be removed. So here the sulfanification type of a reaction is going to take place. Due to that, the foam is going to form. Once this foam is formed, then we can remove it and it will be free from the water. Probably in another day, the in one of the paper or one of the headlines in the news, they were saying that in Bangalore, the one particular lake is not forming any foam due to the lockdown, because all the industries are locating nearby have stopped working. Due to that, there is not formation of a foam. That foam is forming because of the discharges that have been done in for that lake. So now we are going for the last process in a primary process, that is nothing but the sedimentation process. So once it is once the oil impurities, the suspended impurities, the floating impurities are removed, then we are sending it for the sedimentation. Sending it, the sedimentation, sometimes it is done just allowing the suspended impurities to settle. Sometimes the suspended impurities, which are very minute in nature, that will settle at a bottom. Sometimes it needs a coagulation. So if it some if the suspended impurity is not settling at the bottom, then in that case we need to apply the coagulants. We are going to apply the coagulants. Once the coagulants are applied, then automatically they combine, the suspended impurities are going to combine with these coagulants, and they will form a mass, and that will be settled at the bottom, which can be removed easily. So the coagulants that are used are going to be either it will be alum or it will be ferrous sulfate, which will be which will combine with uh, the fine suspended matter, and they will allow them, they will combine, they will form a heavy material, and they will settle at a bottom. In this way, the fine suspended impurities also removed. So by treating a water in a primary treatment, we are going to remove the all physical impurities that are present in a water. Now we are going for the second thing, that is nothing but the secondary treatment. So the secondary treatment is nothing but it is called as the activated sludge process. So the secondary treatment is nothing but the activated sludge process. In the examination, they are going to ask you the activated sludge process. Sometimes they are going to ask you the primary and secondary. So when it comes to the secondary treatment, you need to start with sedimentation. So after sedimentation, the water will be sent for this activated sludge process. So then what is this activated sludge process? This activated sludge process involves the extensive aeration of the sewage water and the process of aerobic oxidation being enhanced by addition of a part of a sludge from the previous oxidation processes into the sewage water. So here we are going to take a small amount of activated sludge. Activated sludge, in the sense, it is a waste which is produced in a previous batch. So why we are taking this one? The purpose of taking this one is that it contains large amounts of microorganisms. So in this case, it is the activated sludge process is nothing but it is the aerobic oxidation. Aerobic oxidation, in the sense, oxidation in presence of air is called as aerobic oxidation. So here sufficient amount of oxygen is given, and the sewage water is subjected for the agitation. Due to that, the microorganisms will come in contact with the organic load that is present in a sewage, and they will combine with that one, and by combining they will form the they will be get digested. Here we are going to say that during the process Here in this case, in case of this activated treatment, the organic matter is converted into carbon dioxide, and nitrogen is converted into ammonia, and this ammonia is further converted into nitrite, nitrates, and the bases that are present in a sewage water form the salts like ammonium nitrate, ammonium nitrite, ammonium nitrate, and calcium nitrates are going to form. So this the aerobic biochemical oxidation or the aeration that will lead to the conversion of heavy organic component into a simple molecules. By doing that, the load that is present in a water is going to be reduced. So this secondary process is generally carried out by two methods. One is a trickling filter method, another one is the activated sludge process. Then this activated sludge process, the systematic arrangement, the arrangement that is used in case of this activated sludge process is as shown in a figure. So it is containing a large tank. It will have the oxygen inlet pipes will be there, and at the top the agitation for the stirring purposes, we are going to have the agitating system. Then it is connected to another sedimentation tank where the clear water and the sediments will be passed to that one. Once it is passed, then the sediment is going to collect at a bottom, whereas the clean water will be there on the top. The sediment which is collected at a bottom, part of it is again used for this activated sludge process, whereas the clear water is removed, and the remaining sludge that is collected at the bottom, it is removed from the outlet and it is used as a manure. So at a one side, the waste water is sent. From the bottom, we are going to inject the air, and then agitating stirrers are kept at the top. So this is the arrangement of the activated sludge. Now, so a known here we are going to say that the the added sludge from the previous oxidation batch is going to known as activated sludge. It contains large number of aerobic uh, bacteria, and apart from that, it's going to contain the microorganisms. The sedimented sewage water is mixed with the proper quantity of activated sludge. See here, we need to check how much quantity of water we have taken, what should be the sludge that we are supposed to supply it. We should not provide the excess also, and at the same time it should not be less also. So based on the amount of the sewage water or amount of the load that is present in a sewage water, we are supposed to supply, or we are supposed to add the activated calculated quantity of activated sludge into the chamber. Then it is a mixture is aerated and agitated for the several hours. Means continuously we are aerating, we are continuously passing the oxygen, at the same time the agitation is taking place for a several time. If you want to see this particular sewage treatment plant, here in case of KLA hospital, we are having last year we have took our students for seeing this particular sewage treatment plant we took. If you all are interested and if time permits or everything goes right, then definitely we'll plan for taking you to show this sewage plant. But the only problem with this one is that it is bad smelling area, so that's going to be a problem here. So during this process, during this process, the organic matter is oxidized. After the process is completed, fluent is sent to the sedimentation tank where the sludge is deposited, and water free from the organic impurity, water water free from organic impurity is removed from one part, and the activated sludge which is settled the sludge which is settled at the bottom is removed from the other. And the organic load after treatment with this one is going to be much lower than the expected. Then the clear effluent water, the water which is clear, that is called as a effluent, it is subjected for the chlorination. Once it is chlorinated, the purpose of chlorinating is to kill the pathogenic bacteria that are going to be present in a water. So once it is killed, then then it will be discharged into the lakes or water, streams or rivers, where the organic load is going to be very, very less. So automatically it requires a very less oxygen, which can be maintained along with the natural sources. So in this way, we are going to remove the organic load that is present in case of this sewage. In this way, the secondary process is going to be completed. Once it is completed, then we need to go for the one more treatment that is called as the tertiary treatment. The purpose of doing this tertiary treatment is to make water completely free from all the impurities that are going to be present. So the other impurities that are going to be present after the secondary treatment is that it may contain a phosphate, it may contain the metal ions, it may be having the some organic components, and apart from that, any colloidal impurities may also be present in a sewage water, or the treated activated sludge treated water may also contain all these things. One is it may contain a phosphate, it may contain the metal ions, it may contain the the organic, minute organic components. Then it may also contain the very fine colloidal impurities may be present in this one. So the first one is the removal of the phosphate. The removal of phosphate is done by treating it with the lime. So the calcium lime is going to be treated with this phosphate, and that will lead to the formation of a calcium phosphate. This treatment is done. The particular pH has to be maintained here. The pH maintained is going to be in the range of 10 to 11. So the alkaline pH we are supposed to maintain. So in the alkaline pH, the phosphates are going to combine with the calcium, and it will lead to the formation of a calcium phosphate. In this way, we can remove the phosphate. If metal ions are present, then these are treated with the sulfide ions, and once this is treated with the sulfide ions, then in that case it is metal ion is going to form the insoluble sulfides. That sulfides can be, again, it will be removed. Then the activated sludge, it is treated with a charcoal. The charcoal is having the more adsorbent character. It absorbs the color. Any color, if it is present, that will be taken out. If it is having any odor, that will be absorbed by the charcoal. Probably you might be knowing that activated charcoal is used in our water filters. Water filter, the charcoal is going to be there, that removes the any suspended fine particles which are having the odor and the color will be removed by this activated charcoal. Once it is treated, then the any organic compound that is present in a secondary treated water is going to be removed. The last but never the least, treatment with alum. So any fine suspended particles that are present in the water, that are going to be removed with the help of this alum. So alum is absorbs the impurities, and it gives a very clear water. So in this way, the sewage is converted into a completely usable water, and this is called as sewage treatment. So this is how the sewage treatment is done, and water is going to be regenerated. Probably you might know, or you don't know, I don't know. In some of the metropolitan cities, there are a large sewage treatment plants are there. They are recycling the water which they are getting, and once it is recycled, they are again reusing it in their day-to-day uses. Or it may be for the gardening, it may be for the uses for the bathrooms and all the other things. There it is used for the drinking purposes. They will take the water, different water, but for the other purposes they are using this treated water. Probably here Hirandani estate in case of Bombay, they're having a large sewage treatment plant. There they are recycling the water repeatedly and generating the water, and the same water is being used in case of the Hirandani estate in Bombay. There are many such estates are there which are reusing. It's a compulsion now. We have very limited water resources. That's why we need to be very careful when utilizing the water. Here in a small villages or small towns like Belgium, we may not find that much of a difficulty, but you go to the metro cities, you will find water as the scarcest thing. It is not possible to get a water that easily. So you might be knowing about Venezuela, a country where water is going to cost more for them. So there are many countries which are not having the freshwater resources. India is a rich country. India is rich in its resources, but we are the persons who are not caring for these resources and we are wasting them. So we need to take care. We need to use the water in a proper way and maintain our resources in a good condition and utilize it for a longer time. Don't think a momentary benefits. Think about a long term, and use it. Be comfortable with the nature and maintain this nature for your future generation also. It's a need of our, every one of us needs to think about this one. Please don't waste a water. Use a water in a priority basis and do that too in a proper way, and automatically all such a processes are not going to be that much required if we are able to. The best method is rain harvesting is the best method. Then unwanted wastage of water has to be stopped. So this is about this water, a wonderful chapter, wonderful unit that we are supposed to study and understand it and follow this. With this, I'm going to complete the fourth module, and now we are left with only one that I'm going to start it from Tuesday onwards. So any doubts regarding this module is concerned, I'm always ready for that one. Anytime you can send me the question, I'll answer your question, and any doubts if you are having, please ask it without hesitation. So with this, I'm going to conclude. Just I'm waiting for you people to ask any questions. So I hope already have displayed the second IA syllabus for you people. Already the circular has been circulated. Even the timetable is also been circulated to you people. I hope you know the timetable also. Have you seen the timetable or not yet? Have you seen the timetable or no? Any one of you please speak a bit.